Shady business like that with people?
The new AR, new balls,
Huh?
new frame. But the motor's fine. The motor's fine. It runs great. Game day. Oh, yeah. Good point. We don't have the chairs. Game day. Oh, yeah. So wait, if I have like study hall study period and I go and then take my attendance and I go rip out like halfway through the period, does that still go?
You missed one in 5 minutes. I've heard that before.
You know, I feel like you shouldn't have to go. If you don't get a credit for the class, then why are you required to go?
Alright, we've got negative 3/20 plus 2 over x equals 5 over 4x. Now we did all before Thanksgiving, all before Thanksgiving break, we were working with fractions, rational expressions. Now we've taken it another step farther and made it an equation, solving the actual equation. What we're going to do is we're good equation solvers, but a lot of us don't like fractions. So that's going to be the plan of attack, is to get rid of the fraction and just make it a normal old plain equation. I can get rid of this fraction by multiplying the whole equation by whatever the common denominator would be. So I'm looking at the denominators that I have now, 20x and 4x. And I'm trying to find the smallest thing that they'll all go evenly into. 20 won't go into 4.
Oh, the
20, and what else does it need to have? An x. Very good. So I'm going to multiply this whole thing by 20x. So that's going to cancel my fractions out. This first time I'm going to show you the steps, but then after that we might skip some stuff. If I take this 20x and multiply it here, negative 3 over 20 times 20x. It's the same as 20x over 1, right? The 20s would cancel out, so I'll just have negative 3x. Okay? I'm going to take the 20x and multiply it here. 2 over x times 20x. Here, just the x's would cancel out, so I've got 2 times 20. Okay, then when I go here, 5 over 4x times 20x. The x's will cancel. 20 over 4 reduces to 5. 5 times 5 is 25. So now what started out looking suspicious is a normal old 2-step middle school equation. What would step 1 be there, the negative 3x plus 40? What would we do first? Subtract 40 like Aaron said. Negative 3x. 25 minus 40. What's your last step? Divide by negative 3, and y'all have got it. Now, anytime there's a couple of sticky situations in math when you got to check answers, make sure they're going to work. Anytime radicals are involved, you're limited because you can't have negatives and be real underneath the square root. Fractions, because you can't have a 0 on bottom. So if I were to plug a 5 back in here, would that make either of these be a 0 on the bottom? No, we just turn that one 5. That's okay, right? That one would be 20. That's okay. So that is your answer. Find the common denominator, multiply the whole equation by that, cancel it out. Like step. Alright, let's try another one. Good.
Yeah, on the that one. How do you know which? Like, because you could take the 5 out.
When you mark stuff out, it's going to be top and bottom. So x's were out.
So it can't be a top and top.
Right. So what you could do here is you could say 5 times 20 is 100, and then 100 over 4. You could do that. That would get you the same thing. But we said 20 over 4 is 5. And then we had the 5 plus 5. Okay. It's got to be, that's top and top.
Okay, so it has to be
Top and bottom. I said it wrong.
Top
You
and
knew
top.
what you meant.
Top and top. Gotta be top and top, right?
Nope.
Counter top.
got 2 over x minus 3 over 2 equals 7 over 2x. What's the common denominator going to be?
2x.
2x.
Yeah, 2x.
Very good. So we're going to multiply this whole thing by 2x, and that's going to be key all day long in this stuff. We're going to get to some bigger, more complicated denominators. We got to be able to figure out what the common denominator would be. All right, if I take the 2x here, the x's will cancel, right? But I'll still have 2 times 2. You all right on that? Can I skip that? We're good? Okay, minus, if I take the 2x here, the 2's will cancel. I'll still have 3 times x. Now, I like this 7. They both cancel. Right? So you just got 7. Nothing to that. Now, what's your first step there?
Subtract 4.
Now, that kid subtract 4, so negative 3x is equal to 3. Last step. Good job, Sir Gibson. So x is negative 1. 7. That's on circle. How are you today, Mr. Bailey?
I'm good.
I'm good.
It's Monday, and we came back from This house goes right. She might be.
Did you not get bored?
No, I hunted the whole time. Pretty fun. Oh, good.
I've been gone.
Yeah, he hasn't even been here.
I've been in
I ain't seen
Oklahoma
him
for
since
11 days.
last Thursday.
Pretty windy.
Did you not do board?
Yeah, I did. Early in the week. Like when I first got out Monday, Tuesday, I was getting very crazy. But Wednesday, stuff started picking up, so it was better.
Yeah, well, then, thank you. Oh, I didn't leave. Went back home. Actually, thanks,
Alright, so we've stepped it up a notch here. Now our denominators are binomials. When we get denominators that are binomials or trinomials, we're going to have to factor them to find what parts we have to know what our common denominator needs to be. And this, the way it's written, we know our common denominator already if we're looking. I think they got it? What would you get? What would you get if you multiplied these two denominators?
X squared minus
Squared
1.
minus 1.
Good. So this denominator factors difference of squares as these two. Right? Just like on the bell ringer, you take the square roots of them. So my common denominator, I could write it a couple different ways. I could write it like this. It's going to benefit me more if I write it in factored form. So I'm going to write x plus 1, x minus 1. That way I know which part I cancel out and which part I don't. Okay? So here's the way I do this. When I get ready, I'm going to distribute this all the way up here to the 3. X plus 1 cancels out, but it still has to get the x minus 1. So I've got my 3 already there, and I'm going to multiply that by x minus 1. Yes, I'll distribute, but I'm going baby steps with us right now. Okay? Bring down my equals, bring down my 1. When I distribute here, x minus 1 will cancel out, so I still have to multiply it by the x plus 1. You follow that? Minus 2, when I distribute it here, the whole thing cancels out. So I just have the 2 there. Alright, let's distribute and simplify and clean up. This will be 3x minus 3. When you distribute a 1 to that, that doesn't change anything, but then you're going to have a 1 minus 2, which will be that, right? Now we got 4 pieces in this equation. You can pick any of the 4 pieces you want to start with. They'll all 4 work. So you're deciding which one you want to get rid of first. So what would you do on this?
Subtract the x.
Subtract the x, Kaylee, is what I would do. Also, so it gets 2x minus 3 is equal to -1. Now, once Kaylee and I did that, we don't have a choice about what to do next. We're to the 2-step middle school equation. We have to add the 3.
Yeah.
So 2x equals 2, which means x equals 1.
Yeah, right.
Now, I'm slamming the brakes on right now. I've got red lights flashing at me. Go back and look at your original problem equation. What would happen if we plugged a 1 in for x on some of those denominators?
0.
Right here, what's 1 minus 1? And what's the one number you can't have on the bottom of a fraction? So my 1 is no bueno. I did all that good work, got a good answer, and he doesn't work. No solution.
So, in order to figure that out, would you have to plug it back into the problem every time?
So we go back and check it. Don't you just have?
Yep. It's okay.
Got it. Bingo, bango. Yeah, they do it. I know.
Alright, we got 4 over x squared plus x minus 6 minus 1 over x squared minus 4 equals 2 over x squared plus 5x plus 6.
You just don't set up like 5 numbers.
Yep. Alright, so what we got to do to figure out what our common denominator needs to be, we need to know what factors we have in our current denominator. So that's going to be my first step, is I'm going to factor every denominator that I can. Okay, so here underneath the 4, if I do a times c there, that gets me -6. What factors of -6 add to +1?
What?
Factors of -6 that add to +1.
-2 and 3.
-2 and +3.
Yeah.
Okay? Underneath the 1, how does that denominator underneath the 1 factor?
X minus 2 and x plus 2.
Very good. It's difference of squares, x minus 2 and x plus 2. Alright, over here underneath the 2, I need factors of 6 that add to 5.
3 and 2.
3 and 2.
Again, give me time.
Alright, so now when we start multiplying by our common denominator, the rule is going to be, if it's in one of your denominators already, it's got to be a part of your common denominator. So I know I'm going to have an x minus 2 to multiply by. I know I'm going to have an x plus 3 to multiply by. I've already got x minus 2, don't I? Yeah. I know I got to add an x to multiply by an x plus 2. Already got both of these. So those 3 binomials, it'd be better if I had enough room to write them out in a row. Okay, so don't think you got to squanch them up like that. Those 3 binomials are my common denominator. Alright, so when we take this to the 4, got my 4, x minus 2 will cancel, x plus 3 will cancel, one I have left is x plus 2. Minus 1, the x plus 2's and x minus 2's cancel. The thing it has left is the x plus 3. Equals 2. X plus 3 and x plus 2 cancel. The thing it has left is x minus 2. You all right on that? Now you got lots of distributing and cleaning up to do. 4x plus 8. When I got a minus 1 here, I'm just distributing the negative, just changing the signs. Minus x minus 3 equal to 2x minus 4. Still got some like terms over there on the left to clean up. It'll be 3x plus 5. Okay, now you got your 4-parter. Pick the part you want to start with. Subtract 2x. I like it. X plus 5 is negative 4. Be negative 9. Alright, now remember we did all that work on the previous problem and then it made our denominator 0, so it was no good. So if I got a negative 9, what would make my denominator be a 0 is if I had one that said x plus 9, right?
Right.
So do we have one, an original that said x plus 9? No. There's no x plus 9s, right? So that's good. Well, I was saying that's what a factor would be that would make this no good. And since we didn't have one of those there. Okay, just add another step. Alright, circle.
No. I could do better.
Alright, we got 2 over x plus 3 minus 1 over x minus 1 equals negative x squared minus 3x over x squared plus 2x minus 3. Alright, bless you. Looking at what we got here. This denominator, x plus 3, is already factored. This one, x minus 1, is already factored. My life is going to be a lot easier right now, Caleb, if this factors as these two. So, a times c, what factors of negative 3 add to 2? 3 and negative 1. So this makes our job a little bit easier now. We don't have to do that factoring step. We already know that our common denominator is going to be x plus 3 times x minus 1. You okay there?
Yeah.
That's the hardest part. Then now we're just going to cancel some stuff out. With my 2, the x plus 3's will cancel out, so it'll still have x minus 1. Okay? With my minus 1, the x minus 1's cancel out, it still has the x plus 3. What cancels out here on the right side of the equal sign? Very good. So we just have negative x squared minus 3x left. Good job. Y'all are all smart fillers or fork smellers, one or the other.
And it is pretty important.
2x minus 2 minus x minus 3. Just did some distributes in there. Did you catch that? Now go ahead if you haven't already. I know some of y'all are getting ahead of me. Combine some like terms. 2x minus x is x. Negative 2 minus 3 is negative 5. Alright. Got something new here. Well, yeah, the last one had an x squared, didn't it? Did it not? So this is the first quadratic one that we've had. Thank you, Cole. When we solved quadratics, you knew quadratic formula, factoring, completing a square, all of that involved having it in standard form, setting it equal to 0 and moving it over. So you got to decide right now, do you want to move this stuff over here, or would you like to move this stuff over here? Either one will work. My personal preference, I like for my A, whichever one's with the squared, to be positive, and right now it's a negative. So I would add it. So I would move this stuff over. Is it alright if we do that? Okay, so I'm going to add the x squared, and it doesn't have a like term, so it's just going to be a positive x squared. The 3x doesn't have a like term. Yes, it does right here. 3x and x, that was almost stupid, is 4x. So I've got that taken care of, and there's still a minus 5 there. Now we're in standard form. Need some factors of negative 5 that add to 4.
Negative 1 and 4.
Negative 1 and 5.
Or 5, yeah.
Now, a lot of y'all, we were doing this in Algebra 2. Once you know the factors, y'all know the solutions. You just make them the opposite signs. But I've still been writing it out for some of us that need it. So we get 1 and negative 5. Okay? So how do those test out in our denominator check? That'll work in both of those, won't it? What?
Oh, no,
What
1.
would happen here if I put a 1 in here?
0.
Well, minus 1 is 0, so the 1's no good, is it? Kick it to the curb. Get out of here, my, sorry, 1.
Just x minus 5.
Just x minus 5, negative 5.
Pretty simple.
I like that.
My birthday's in 2 days.
Will you be 17?
No, 12.
Well, then,
Dude, it is in 2 days.
Whoa! Yeah, I'll be 7.
Alright, you got 7 over 6x plus 3 minus 1 over 3 equals 2 over 2x plus 1. Now you're going to try this one. There's only one of those denominators that can be factored. So I gave you a little bit less work. The first denominator, the 6x plus 3, is the only one that can be factored. The rest of them are already in simplest form. So I'll be quiet and let you think for a minute, and I'll just add hints as we go along. So just be trying it right now, and I'll add a hint here in a minute.
Whoa there.
Hey, come on now.
You know what it says. Yeah, he said where you there.
We're almost done. Can you wait a little bit? A minute. If you can, go ahead. But gotcha. If you can.
Yeah, just wrote it.
But you can do that. It's just harder for me to see what to mark out if I do. So that's the reason I write it as factors. What Caleb was saying, he knows the common denominator is what I wrote there in red, but he wrote it as 6x plus 3. That's the same thing. That's fine. I'm a lot more simple-minded, and y'all know that. So I see what I can mark out easier if I write it as the factored form. That's the only reason I do that. Not right now. just told two guys to wait, and then you like trying to like be the favorite one.
I'm sorry, I just break this whole group here.
So your punishment for breaking the handbook rule is you just have to sit here and hold it. Okay. Well, it says you didn't have water.
They just told me clear bottles.
Pretty clear, guys.
The only thing I got in trouble for was cut, like, if I brought like a cup of something, okay, Coach Moore made me tell that for me.
Cody Johnson, he's that guy.
He's like 22.
Yeah.
He's gone.
Sounds like it.
But he's rich, that's all right.
You know, his daddy's rich, you know, works for his daddy.
So he's rich.
Daddy's you just gotta be able to do it up. You like to push this roll thing down, you gotta hurt.
Alright, when you distribute your common denominator, on the first piece, everything would cancel out. You just have your 7. On the -1, the 3's would cancel out, so you would still have the 2x plus 1. On the 2, the 2x plus 1's would cancel out, so you would still have the 3. Okay, I know that's 6, and yes, skip that step if you can. I just wanted everybody to see where everything came from. This -1 times that, all that does is changes your signs. So that's 7 minus 2x minus 1 is equal to 6. Combined, 7 minus 1 is 6. Now we got to this point in first period and everybody started saying no solution. Not necessarily. 0 is what you're going to get here, right? 0 is a possible number, so we still have to check it and see. Maybe I got ahead of myself. Subtracting, see why it's 0 now? And then divide by -2. 0 divided by anything is 0. So they saw they were getting a 0 and said, well, you can't have a 0. You can have a 0 as long as your denominator is not a 0. So let's go back and look at our denominators and see if that would make any of them a 0. 6 times 0 is 0, plus 3 is 3. So that's okay, you can have a 3. That one you don't change, it's a constant. 2 times 0 is 0, plus 1 is 1. So that's okay.
Yeah.
So that is a good answer. Okay?
That's what I'm going to check.
Yep.
Okay.
There you go.
Yep.
There we go.
Alright, so where we go with this tomorrow? Still going to be fraction equations, rational equations, but they're going to come out of a lot of word problems and stuff like that. You're going to have to make some tables and all that kind of stuff. Okay, doke?
Yep.
Alright, that'll be a wrap. No, I didn't do one this morning.